Okay, so these are the office hours for Tuesday, December 6th. I haven't gotten that many questions emailed to me, but there were some students who had questions on problems 1, 2, and 3. However, I'm not going to cover those because those are actually almost identical to an in-class example that I already worked. So if you want to know or want to see how to do that one, review that lecture where I go over that in-class example. You might also want to watch some of the lecture from Friday, because one of the examples from a previous final exam might provide some guidance, might provide some ideas on how to solve that one as well. So that's all I'm going to do for problems 1, 2, and 3. I haven't gotten anybody who's expressed a concern about problem 4, but then there were several people who expressed a concern or had some questions about the last problem. So that's the one I'm going to focus on here in my office hours, is problem 5. So problem 5. You're told that you have a 3-phase 70 Hz AC induction motor with 4 poles rotating at 1900 RPM when connected to a load of 20 Newton meters. The Z motor is impedance seen looking into the single phase of the motor under normal operation as shown. And of course, what is the new motor speed if the required torque increases to 34 Newton meters is the first question. Well, this is very similar to a lot of the problems from last time, the previous homework assignment. So first thing you want to do is you want to find NS using the 70 Hz electric frequency and the 4 poles. Then you want to find the slip, I'm going to call it S1, that corresponds to the speed of 1900 RPM, and you can get that from NS minus NM all over NS, so that equation's on the formula sheet. Once you have slip, then you can use the fact that torque developed 1 over torque developed 2 has to be equal to S1 over S2. And so you can use this to find your new slip because you have your new torque. You have 20 Newton meters from before, and now you have it at 34 Newton meters. And so from those values, that allows you to find your S2. And once you have your S2, then you can use the equation relating slip and speed to get your speed N sub M, or NM2, from the slip. And so that's how you solve part A. For part B, well, basically, you look at that equivalent circuit diagram, and you want to find the impedance Z motor looking in. And that Z motor looking in is, you do the same step that I did in class, same step you did on problem 1 and problem 2 or 3, I think it's problem 3, on this homework assignment. You need to find the equivalent impedance of the inductor in parallel, or excuse me, the inductor in series with the RR prime, and then that in parallel with LM, and that in series with RS and LS, just like you did on the problems and just like I did on the in-class example. And I should mention, just like I did, actually I guess I didn't find Z motor for the example from the exam. That was a different exam I was thinking of. So Z motor, you find it just like I did in class. You find the equivalent impedance seen looking in for the value of slip given by S1. And so that's how you solve for part B, is you just use the 70 Hertz. Of course, you have to convert that 70 Hertz into the omega sub B in order to find the impedance, and so that's going to be 2 pi times 70. And then you want to find your inductances, for example, is J omega sub B or J omega times L, whether it's LM, LS, or LR prime. And then you have those complex impedances that then allow you to find your impedance Z motor looking in. And you solve that in part B for the first slip, the S1 that you found in part A. And then in part C, you do the same thing. Part C, you work from S2. So the electric frequency, of course, doesn't change. So you're still using the 70 Hertz times 2 pi. And you just solve it again. You solve the impedance again at the new slip associated with S2 and find that Z motor. And so that's how you solve this problem 5. So hopefully this helps.